Oh, yeah. Okay, you guys are green. So let's draw a Bohr diagram together. You're going to need your notebooks out, and then I'm going to give you a paper, and we're going to work on some ions. But let's draw a Bohr diagram of, let's say, chlorine. Okay? So when we draw Bohr diagrams of chlorine, am I recording? I hope so.
Yes.
Okay. Yep, I am. All right. We've got a nucleus. And in the nucleus of chlorine, how many protons do we have? Don't guess. I don't want guessing. You're guessing. That's called guessing. Fine. Chlorine, hold on. Let me pull up a reference table so that you're not guessing anymore. Shayla, go ahead. 17 is a beautiful number. You guys are almost 17 years old. What are you, 15 right now? 14, 15? All right. Won't take long. You'll be 17. Okay. Chlorine is atomic number 17. I said what? Oh, okay. That means it has 17 big positive protons in the middle. Somebody wants to visit us. Thank you, Lila. All right. Also, we learned yesterday that we have these rings called energy levels. I don't even. Okay? And these energy levels are what Bohr... Ooh, look at that fancy shape that it made. It looks like a pizza pie. How many energy levels are around the chlorine? 3. And you know that because when you look at chlorine in the bottom left corner, there's a bunch of numbers. 2, 8, 7. Yes, no? Okay. So now, what does the first number, that 2, mean? 2 electrons in the first level, and we put them on opposite sides. The next level, my circles are not very circling. There we go. Is that a little bit better? The next level has how many electrons? 8. And we're going to put them as 12, 3, 6, 9. And that's the first 4. And the second ones are going to go at 12, 3, 6, and 9. And now I have 8 in the second ring. This third ring is going to have how many? 7. So we go around once, and we almost make it to the other side to get to 7. What is this final ring on the outside here called? Charlie. Valence shell. And I asked you to maybe put a star next to it because that is the most important vocabulary word I talked about yesterday. The valence being the outside shell. And it has 7 electrons in it. How many valence electrons does it have? 7 valence electrons. Okay. How many valence electrons does it want to have? 8. There are all the elements on the periodic table want a full valence shell. Now, most of them want to have 8 because 8 is the maximum number of electrons you can have in your valence shell. There are a couple, like helium, only needs 2 to have their full valence shell. Keep that in mind because they only have 1 ring, and the first ring, the first energy level, can only hold a maximum of 2 electrons. So keep that in mind when I say full valence shell. Okay? All right. So what is it going to do in order to complete this valence shell? Did we talk about this yesterday? Okay, so here we go. It has 7. It's wandering around in the universe, and it has 7. It's not very happy. It's actually kind of aggravated because it only has 7, and it wants to have 8. So what is it going to do? It has 2 choices, doesn't it? It can either go up to somebody and say, give me an electron, and be a bully, or it can lose these 7. If it loses these 7, then this shell becomes its valence, and it has 8. So let's think about this for a second. If you have $7 in your pocket, and you want to buy 4 candy bars, at $2 a piece, right? But I only have $7 in my pocket. I might say, hey, Jack, do you have $1? And he might say, okay. And he gives me $1. Now I can buy my 4 candy bars. Or do I say, well, I'll just give away my $7 so I can get to those $8 that I have stored in the bank, and bank in quotation marks, right? Would I just give away my $7 to somebody so that I can get to the $8 I have stored away? No. So because he's so close to having a full valence shell, that chlorine is going to go out and is going to find somebody who's willing to give away their electron. And when they do that, that electron, I'm going to make the electron green, is going to go right there. The only reason I'm making it a different color, hold on, it's coming. I can find my, oh, you can't even see that it's a different color. Maybe red is better. Okay? The only reason that I'm making it a different color because I want you to understand that that electron's coming from somewhere else. Okay? Now, we've got a problemo because this chlorine has 17 protons, which are positively charged. If I have 17 protons, oh boy, I don't know why I picked such a big one to draw, but here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It has 17 positives. And when it didn't have this red electron on it, can I erase that? I don't even know if I can. Okay. Let's pretend it doesn't have that electron from somebody else. It had 17 electrons. It was neutral. But as soon as I put that extra electron on there, now it has an extra electron. Is it neutral anymore? No. Okay, now the word neutral, I said way back in the beginning, neutral means atom, right? Has the same number of protons as it does electrons. This is no longer an atom. This is now what we call an ion. Okay, so let's write that down. An ion is a charged particle. How does it become charged? It can steal them, okay? It can gain electrons from somewhere else, okay? So it becomes an ion by gaining electrons, or, which I didn't draw yet, losing electrons, because if somebody's gaining them, somebody else has to be losing them, right? The one that they stole them from. That's how you become an ion. You either get more electrons or you're losing electrons. I'm going to draw the one for losing them in a few minutes. And when you gain an electron, what does your charge become? Your overall net charge. Negative. So if you gain an electron, you become a negatively charged particle. And that negatively charged particle has a name. I hate to break this to you, but more vocabulary. That is called an anion. A who what? An onion. It's called an anion. A negative ion. An ion. Okay? Not an onion, but an anion. Okay? If you lose an electron, that's the funniest thing I've heard in a really long time. You become a positive ion, positive charge. You do not become a leak. But this one's just as funny. You become a cat ion. Carrot. We're making soup here. We got onions, leeks, and carrots. Okay? So, a cat ion, cats have paws, are positive. Okay, roll your eyes, groan. But then I get to show you one of my favorite things, because I love memes. Where's my thing? Oh my God, I love them. They're so fun. All right, so let's go. I put it on the blue class already. I didn't put it on yours. So let's look. What does that say? Cations are positive. Good. This one is my favorite. Cations are positively charged. Look at that cute little kitty. And then this one says cations are, it does look like me. I look just like that. An ion with a positive charge, the cutest ion ever, just like Jack.
Look, I brought Anthony with me.
Hi, Anthony. How are you?
Good, how are you?
I'm doing just positive. All right. I have to finish this lesson. Go away.
Positive is fucking real.
I know. I'm just downright hilarious.
You are.
I know. Okay. So, if you gain an electron, you are an anion, not an onion. And the way you can remember anion, a negative ion, and the way you can remember cation, besides the cute little kitty there, if you write cation and you put the T in the middle, let's change the color to hot pink. It kind of looks like a plus sign, right? So that's another way to remember cations are positive. What's the matter? You like the picture of the cat better? Lily, you all right? Need some water? Okay. All right. Any questions on that? Okay. Now, what kind of things become cations and what kinds of particles, I'm using the word particles now, not atoms, because we're going to start changing their charge, become anions. So if we look at the periodic table, if I can find it, where the heck is it? Here it is. Okay, so here's the periodic table. Let's look at group 1. Groups go up and down on the periodic table. Look in the upper right-hand corner of all of these boxes. Do you see this little plus 1? That means that those elements can form a plus 1 charge. So if you look at sodium, it has a 281. Sodium's nucleus, I'm not writing the number of protons in there. I don't know why, but I'm not. And then you have 2 electrons in the first ring. I'm getting lazy. 2, 8 in the second, and 1 in the third. So let's write them in. 1, 2, then 1, 2, 3, bless you, 4, 5, 6, 7, 8, and then 1 here. Unlike the, what did I do here? Chlorine, the sodium has 1 valence electron. Is it going to be able to go out into the big bad world and find somebody to give him $7? 7 electrons? No. So how is he going to get a full valence shell? He's going to what? Blessed, look up here. He's going to lose 1. He's a loser. He's a big loser. Okay? So when he loses this electron, look what happens. This is very exciting. This, did you see that? Yeah. Wow, that's funky. All right, that valence shell goes away. And now does he have 8 in his valence shell? Yes. Okay, so we have to have a way to designate that these particles either gained or lose electrons. So in this case, we have sodium. Do you remember what goes in the bottom left corner? Atomic number. In the upper left corner is the mass number. Well, we're going to put a number in the upper right-hand corner. I know, we're running out of corners here. So in the upper right-hand corner is going to be the charge on the particle. If there is nothing written there, then it is an atom. If there is a number written there, like +1, it's not a good +1. Okay. Now we are telling the reader that that sodium is charged. How did it become +1? Did it gain or lose an electron? It lost how many? 1 electron, because it became positively charged. Okay. So when you have a positively charged ion, I can call them ions now, they lost an electron. The number in the upper right corner is what's telling you what it lost. So if I write Ca with a +2, okay, let's think about that for a second. How many protons does it have? How many electrons does it have? How do we find protons? Atomic number. And so for calcium, the atomic number is 20. Okay? It has a +2 charge, which means it lost electrons. How many did it lose? 2. So how many electrons does it have now? 18 electrons. Is this a cation or an anion? It is a cation. Meow. Because it has a positive charge. Look at that fluorine. How many protons does it have? 9. How many electrons does it have? 9. Okay. It has no charge written on it. If I wrote fluorine with a -1, now it has 9 protons. And how many electrons? 10 electrons. Because it gained an electron. This is an atom. This is an ion. Why do atoms form ions? What's their main goal? Ash? To have a full valence shell. That's their goal. Okay? Now the full valence shell can hold how many electrons max? 8. There are a couple that'll be full with 2. That's the ones that only have 1 ring. Because that first ring can only hold 2. That's the maximum. So hydrogen and helium and lithium and beryllium, they form ions that will have a full valence shell with only 2 electrons in them. Keep that in mind as we go through this. All right, let me stop this for a second. Okay. Let's flip over to that. Okay. This will be easy. We're going to bang this out, this top piece, in 2 seconds, right? It says, what's its atomic number? Where do we get atomic number from? Periodic table. So in front of you, you should have a periodic table sitting right there in front of you. Okay. You cannot do this class without that periodic table sitting in front of you. Nobody's guessing, right, Megan? She's like, yeah. Well, you went 10, 11, 12, remember? Feel targeted. It's just love. Okay, how many protons, or what is the atomic number of carbon? 6. Okay, I'm going to zoom in and make my pen a little bit smaller. These are atoms. Okay, if they have 6 protons, they have 6 electrons. Find carbon. What group number is it in? 14. Good. How many valence electrons does it have? 4. Okay. Can it make cations or anions? When you look in the upper right-hand corner, there are 3 numbers up there. These are the possibilities of what carbon can do. Carbon can gain 4 electrons, lose 2, or lose 4. The top number is what it does 99% of the time. But in this case, we're going to write that it is going to be able to do both. It can make both cations and anions. All right, look at oxygen. Let's blast through this. What's its atomic number? 8. How many protons? 8. How many electrons? 8. What group number? 16. How many valence electrons? 6. Cation or anion? Say that again. Anion. Good. It only forms a -2. Okay. Potassium. What's the symbol for potassium? K. So fill that line in. Oh, thank you, Charlie. Ah, I just fell off my chair. Okay. Potassium. So potassium has 19 as its atomic number. 19 protons, 19 electrons. It's in group number 1. How many valence electrons does it have? 1. And it will form a cation. Okay. Now I want you to, I don't remember if I pointed this out before, but I want to point it out now. Look at all the elements in group 1. How many valence electrons do they have? 1. All the elements in group 2. 2. Then 3 through 12 gets funky. Forget about those for a minute. All the elements in group 13 have 3. All the elements in group 14 have 4. That's not a coinky-dink. Okay? That's how the periodic table is set up. So all the elements in those groups, 1, 2, 13 through 18, will have the same number of valence electrons. All right, arsenic. What's the symbol for arsenic? Anyone know? AS. Good. So that's atomic number 33. So that means these first numbers are 33. It is in group number 15, which means it has how many valence electrons? 5. And it will form both, I believe, right? Okay. Both. Iodine. Iodine is number 53. It's in group 17, so it has 7 valence electrons and will also form both. Okay. Calcium. 20? Is it 20? Yeah, 20. 20, 20, 20. Group number uno. No. You're lying, Kaufman. You're lying. All right. Group number 2. So it's going to have 2 valence electrons, and it will form a cation. You'll notice that the elements that are on the left side of the periodic table will tend to form positive ions. Those are the losers because they have less valence electrons. And the ones on the right side will form negative ions most of the time because those are the ones that have almost full valence electrons. Yeah, go ahead. All right, boron, 5, 5, 5, 13, 3, and cation. All right, last one. Neon. Neon is number 10. It is in group number 18. How many valence electrons does neon have? 8. Does it form a cation or an anion? Neither. Okay, so it does not form any ions because it already has its 8 valence electrons. Capiche? Okay. All right. down at the bottom. Chlorine with a -1 charge. Let me point out, I generally write my charges like that with a -1. Sometimes in textbooks or worksheets they'll put 1-. It's the same thing. Okay, so don't get confused. Sometimes they'll just do chlorine with a dash, like that. That means minus. Okay, if they do sodium with a plus, that means a +1. Just so you know, putting that out there. All right. Chlorine, how many protons? 17. If it has a -1 charge, how many electrons does it have? 18. Potassium, 1 plus 1. Potassium is number 19. If it has a +1 charge, it's going to have 18 electrons. Good. Sulfur with a -2. 16 is its number of protons. How many electrons does it have? 18. Wow, 18, 18, 18. Look at that. Okay, strontium. Strontium is atomic number 38. Okay, with a +2 charge, it's going to have 36. Beautiful. Aluminum has 13 protons. So how many electrons is it going to have? 10. Okay, so for some of you, I might be going a little bit fast. This number is the positive number. This number is the negative number. So 13 positives and 10 negatives gives me an overall +3 charge. All right, phosphorus with a -3. So phosphorus has 15. If it's a -3, it's going to have 18. And silicon with a -4. Silicon usually has 14. Now it's going to have 18. They really liked 18 on that worksheet, didn't they? Okay. Last thing for today. If you have 56 protons, what element are you? See it over there? 56? That's barium. All right, now look at your protons and your electrons. How many protons? How many electrons? You've got 56 positives and 54 negatives, so you've got more positives than negatives, which means your overall charge is positive. So this has a charge of +2. Okay, 87. What element is 87? Fr. What's its charge? +1. All right, 84. That looks like polonium to me. Polonium, and what's its charge? -2. Beautiful. Okay, 50 and 46. Tin, Sn is tin. What's its charge? +4. All right, 32 and 36. What's 32? Germanium. And it looks like it's going to have a -4 charge. 55 is going to be cesium with a +1 charge. All right, last one. Number 12 is magnesium. What's its charge going to be? +2. Okay. So that's the first side. I also taped it. If you need to watch it again, go ahead and watch it. On the back, you have some more questions. I want you to work on those by yourself, and then tomorrow I'll give you the answers for them, so you can check yourselves.